All right, so we're going to have you in this warm-up find just the value of x. Some other things to note, you got 60 and 61 for homework tonight. Also, your problem set is due next class period before class starts. Needs to be uploaded on Schoology. So pause the video, do your warm-up. When you hit play, it'll ask you to submit your answer, and we'll go through it. So we'll call that one the blue triangle. So we've got x, z, and 5. We'll call this one the green triangle. We got to tilt it so there's z, here's y, and here's 12. And then we've got the big triangle, which that's 5, 12, and 13. So we want to find x. So we've definitely got to do x from the blue triangle. Well, notice we have a variable z in the green triangle. That won't help. So it looks like the other triangle we want to do is the red one. That's 5. So we'll take something else we know from the blue triangle, which is 5, and put it over the spot that matches that in the red triangle, which is 13. We'll cross multiply and solve, get 13x equals 25. And when you divide by 13, you get x equals 25 over 13. If you tried to put that as a decimal, it doesn't come out nice, and it did not ask you to round, so that would be an incorrect answer. You need to leave it as 25/13 because that's exact. Looking at your homework, there's that triangle. Here's this triangle. And if you set up a third one, we didn't end up using this one, but it was nothing, nothing, and then we had this was x plus 3. So again, we need two sets of sides where there's only one variable in there. So that's why we wanted to do the 3 from the blue over the 6 from the green matches the 6 from the blue over the x from the green. And when you cross multiply and solve, you end up getting 12. And your next one, after you label everything, this was our blue. This one here is the one that we actually didn't know anything for. And then that was our red. So we had x from the blue over 4 from our red is equal to 4 from the blue over 8 from the red. And when you cross multiplied and solve, you got x was 2. So this one we had to draw our own picture. So you've got basically the picture we've seen in all of them. The hypotenuse is split into 4 and 9. And the altitude, that's straight up and down, is x. So this triangle here would match that triangle there. This one is that one. And then if you tried to draw the big one, the only thing we knew was the 13 there. So the ones I have as blue and red are the ones we'd want to work with. So it's 4 in the blue matches x in the red. And that's equal to x in the blue over 9 in the red. And when you cross multiply and solve, you get 6 inches. Make sure you have your units on it because they gave us units in the question. 13, again, we had to draw it out for us. When you draw it, make sure to draw it so like this point's really close to the altitude, this one's really far, because then that makes it just a little more drastic of what's going on. So there's our red. We'll maybe make this one be green, which that was this that I drew. And then the last one here. So that one there, which is what I called C initially. Oops, sorry, no. This is C, and this we knew was 12. So we needed to be able to find the C, and C also happened to be in the red triangle here as well. So what I did is I did 3 from the red over x from my green is equal to x from the red over 9 from the green, and that got square root of 27. And then did Pythagorean theorem over here to find C. Squaring a square root gives you just the 27. Eventually you work through and you get 6 centimeters. This triangle here matches that one there. That triangle there is the one that I didn't show. And then this is our big triangle here. That matches that one there. So the sizes don't match. The colors are what we would want to match. So you got 2 from the red, matching x from the blue, x from the red, matching 18 from the blue, and when you cross multiply and solve, you get 6. That one matches that one. That's the one I don't have shown. All we would know is that that one's 40. And then this big one, we had to spin it. Our hypotenuse was 45, and that was x. So we had x in my red over 45 in my green equals 5 in my red over x in my green. And when you cross multiplied and solved, you got x equals 15. So today we're going to do a little bit more practice with the proportions in right triangles, because it can sometimes be a tricky topic. And then the second half of the video we'll do what's called the side splitter theorem, which is usually not too terrible. All right, so we want to find all the values here, x, y, and z. So I'm going to start out with this triangle here, and I'm going to twist it and flip it and draw it like this. So this is my 4, y was my hypotenuse, and x was that longer leg. Now, as I'm writing these out, I always say in my head, long leg, short leg, and hypotenuse. If you have separate colors, you can feel free to trace them and do separate colors. So my short leg was x, the long leg was 9, and the hypotenuse was z here. And then in the huge triangle, we've got to twist that to the left. So y was the short leg, z was the long leg, and 9 plus 4, so in other words 13, is the hypotenuse. Well, notice if we use the red and the green, and we use the short leg and the long leg, so use this, 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 and this, our only variable will be x. So we can do 4 from the red matches with x from the green. And then x from the red matches 9 from the green. Cross multiplying gives us x squared equals 36. And if we take the square root, we get x is 6. So everywhere we had an x, we now have a 6. Well, usually after you do one of those, you can do some Pythagorean theorems. So let's do in the red triangle, we now have 4 squared plus 6 squared equals y squared. That's 16 plus 36 equals y squared. Add those together, that's 52 equals y squared. We'll take the square root of both sides. When you punch in square root of 52, it doesn't come out nice. So we'll do menu number factor for 52, and that'll tell us 2 times 13. So just a reminder of that. So if you go to a calculator page, you can go menu, number, and factor, number 3, put in that 52, and that's where I got the 2 times 2 times 13 from. So you do that anytime the square root doesn't work out nice. For each pair, you put 1 out front, so we have 2 square root of 13 for y. Well, if we go to our green triangle, we can do a Pythagorean theorem for that one, because we have the 6 for x, the 9, and the z. So I have 6 squared plus 9 squared equals z squared. This is 36 plus 81 equals z squared. If we add those up, we'll get 117 equals z squared. Take a square root, and when we do square root of 117, it doesn't come out nice. So do your menu number factor, and you'll get 3 times 3 times 13. So one of the 3's will go out front. So 3 square root of 13 is our value of z. If we go down to the bottom, we'll look at letter A first. We'll start with this tiny one. If we spin that around, our short leg is 3, the long leg we don't know, and the hypotenuse is x. In this triangle, if we spin it clockwise, the hypotenuse is y, long leg is 9, and we don't know the short leg. And if we look at the huge triangle, we have x for the short leg, y for the long leg, and 9 plus 3 or 12 for the hypotenuse. So notice in the red and the blue, we could use our hypotenuses and the short legs to find x. Or you could use the green and the blue to find y. It's your choice what you want to do first. I'm going to do the x's with the red and the blue first. So I'm going to have x in the red over 12 in the blue is equal to 3 in the red over x in the blue. So when we cross multiply, we're going to get x squared is 36. Square root of each of those will give us x equals 6. So this is 6 now, this is 6 now. Well, now in our blue triangle, we can just do a Pythagorean theorem. 6 squared plus y squared equals 12 squared. That'll be 36 plus y squared equals 144. If we subtract the 36 over, that'll be y squared is equal to 108. Take the square root of both sides. Square root of 108 doesn't work out nice. So we can do menu number factor. We'll get 2 times 2 times 3 times 3 times 3. So we got a pair of 2's, a pair of 3's, so one goes out front for each. 2 times 3 is 6. So we just get 6 square root of 3 for y. Moving over to B, they tell us this whole thing is 16. 16 minus 4 tells us that part is 12. So we can set up our triangles. X for the long leg, 4 for the short leg. In this triangle, we have x for the short leg, 12 for the long leg, nothing for the hypotenuse. And in this triangle, if we flip it and spin it, nothing for the short, nothing for the long. The hypotenuse, though, we know is 16. So it looks like we want to work with the blue and the green. So x in the blue matches 12 in the green. 4 in the blue matches x in the green. Cross multiplying gives us x squared equals 48. Take the square root of both sides. Square root of 48 doesn't come out nice, so do a menu number factor. We'll have 2 times 2 times 2 times 2 times 3. 1, 2 goes out front for each of those pairs. 2 times 2 is 4, so we get 4 square root of 3, 4x. So one last proportion and right triangle one. I'll make that one green. We got 3 for the long leg, 2 for the short leg, and the hypotenuse we don't know. This one, if we spin it, 3 for the short leg, x for the long leg, hypotenuse we don't know. Now you might recognize that we're good to go right here, so it's up to you if you want to draw the third triangle or not. Third triangle, don't know, x plus 2. So working with the green and the red, we could have 3 in the green matching x in the red. Goes with 2 in the green and 3 in the red. Cross multiplying gives us 9 equals 2x. When you divide by 2, you could say either x is 9 halves, or that's a terminating decimal, so you can leave it as a decimal as you want if you want, so 4.5. So the second half of this video, we're now going to look at what's called the side splitter theorem. If a line is parallel to one side of the triangle and intersects the other two sides, so we're saying those two are parallel, then it divides those sides proportionally. So let's call this little side A, this part B, that part C, and that part D. So there's basically two proportions you can set up. You can do like left over left, right over right. So you could do A over B matches with C over D. Or you could do left to right, left to right. So you could do A over C equals B over D. Notice in both cases when you cross multiply, you'll have AD equals CB. So that's only if we know they're parallel that we can do that. So let's look at some applications of this. So we could take 8 from the left over 6 from the right equals 10 from the left over x from the right. If we cross multiply and solve, we'd get 8x equals 60. And if you divide by 8, you could either have x is equal to 15 halves or 7.5. Now you could have done this as similar triangles also, and thought of this as that triangle versus the huge triangle. And I just want to show you that you'd get the same thing. We were able to do the side splitter because we had the parallel lines, but if you did similar triangles, you would do 8 in the red matches 18, the whole thing in the blue. You would have 6 in the red matches x plus 6 in the blue. So 6 times 18 would give us 108. 8 would have to distribute to both of those, and that would be 8x plus 48. When you subtract the 48 over, you'd get 60 equals 8x. And notice that's where we were here, so you're going to end up as the same answer. So you could do these triangle ones either as similar triangles or using our new side splitter theorem. So here we got the parallel to the third side, so we can do our side splitter theorem. So we'll do 2x over 12 equals x plus 4 over 9. When we cross multiply, we'll get 18x. this 12 is going to have to distribute to both those. So we'll get 12x plus 48. We'll subtract the 12x over. That'll give us 6x equals 48. And when you divide by 6, we just get x equals 8. Moving down to the bottom, we've got multiple parallel lines. Well, this is still just our side splitter theorem. We could do A to B equaling C to D, or we could go across and we could say A to C equals B to D. In either case, when you cross multiply, you get AD equals CB. Flipping over to page 59, we'll see if we can apply that. Notice they did A over B. So A is matching with B. And then we've got something over E. Well, if A went with B, that green and that blue, what's going to go with E? It would have to be E. In the next one, F goes with E, they're saying. Here's F goes with E. So then C has to go with question mark. Well, the missing part for the blue would be B. Next one, D goes with A. So D, they're saying, goes with A. And then B plus C is in the bottom part, so that should be here. So B plus C has to go with what? Well, that's going over two parts, so that should match with E plus F. So you're just matching up the parts to set up the proportion. Going down to the bottom, we can solve for a variable like that. So maybe we'll have 4 match up with 5 going across. That should equal to 6 matching up with x. And again, we can do this side splitter theorem because those are each parallel. Cross multiplying gives us 30 equals 4x. And if we divide both sides by 4, we can either say x is 15 halves or 7.5. Well, in this one, notice they're giving us the whole thing as 24. So you can do it with pairings. We're going to say x matches with 8, and then we're going to say 24 matches with this whole pairing here. So that would be 24 over 20. 20 times x gives us 20x. Eight times 24 8 times 24 will give us 192, and divide by 20, and that will give us, if you do it in decimal form, 9.6. That is a terminating decimal, so it's okay to leave it like that. Or if you had it in fraction form, that would be 48/5, and that would be fine as well. So you got your regular homework for day 9. Also make sure to have the problem set turned in before the next class period. Have a great rest of your day.